Hi, and welcome to our session. For the next hour, we're going to be talking with some of our Nexus 1000V customers and discuss what they've been doing in their own production environments to take advantage of the technology and solve some of their business problems. So we released the 1000V about a year ago, and we've gotten a lot of good positive feedback from customers in terms of how it's helped them address some of their virtualization challenges and some of the things they've been able to do to help scale their virtualization strategies. So basically what we're going to do is we're joined by 4 of our customers. I'll take you through the introductions in just a couple of seconds. They're going to spend about half an hour talking about their production environments, the kinds of problems they've been solving with the software, some of the challenges they've run into. I'll run through a couple of questions and we'll open up the floor for a Q&A. So there is a microphone over in that aisle over there, and we'll wrap up the hour with questions from the audience. So, guys, thank you for joining us. I know it's at least a little bit stressful, if nothing else, sitting up here chatting with us. So we have Greg Smith from SunGard, Emil Verasosa from Sutter Health, Algie Seat from Fujitsu, and then Ken Schroeder from Cisco IT. So each of them, we've got a good mix of different types of businesses, different business models, different production environments. So hopefully you'll hear and see things that are relevant to what you're trying to do in your environment. So since my goal is to stay out of the way as much as possible, I'll hand things over to Greg.
Thank you very much. My name is Gregory Smith, as he said, from SunGard Availability Services, and my role over at SunGard is primarily around being the product architect for our shared enterprise hosted cloud product that has been in development and has been in various stages of launch with customers running on it starting back in February of this year. And so with that, I've been working a lot on trying to play into a lot of the concerns that people have around security, around availability, and around and just general privacy and performance concerns around cloud. And so with that, we actually went with a architecture that was primarily focused on a combination of Cisco, VMware, and EMC, starting with a reference architecture that was put out there by the 3 of those groups, which is called vBlock. And that does leverage the Nexus 1000V for networking. It leverages the Cisco UCS for the server side, and then MDS server switches and Nexus networking gear. So very much Cisco is at the core of that architecture. And some of the biggest concerns that we've run into have been just that around security. And so we're not new into the cloud space and not new into virtualization. We've been doing fully managed virtual infrastructure since 2005, which a lot of people have used as a private cloud. We've been doing recovery, and actually 2 years ago, we had a first cloud product out with a virtual server replication, allowing people to recover to an environment. But we just finally started to enter the cloud space now. And it's because of those concerns around security and multi-tenancy that made us actually hold off a little bit. And we were able to solve some of those by the features that we got through the 1000V, through the Cisco architecture, things that allowed us to put multiple layers of wrappers and security on the networking side. Things like private VLANs, things like actually being able to take and move entire customer environments back and forth, the port profiles that we have allowed. And primarily, it just comes down to being able to take those new technologies to solve the problems that we could only solve physically before. One of the other features that we've leveraged that you can't actually use it any other way in a virtual environment is a technology called Port Protect, the ability to actually, at an individual VM by VM level, handle crosstalk between VMs, be able to say, no, you cannot talk, or yes, you can talk. And there were a lot of pieces out there on the marketplace. There were VM safe API driven products. There were in hypervisor firewall type products that could have been leveraged. But we've been doing a lot of this security work in our managed environments for the last, about somewhere 7 to 10 years. And there were proven technologies that existed inside the Cisco switching environment that it turns out with this in-hypervisor type intelligent switch, not just the distributed switch, but a more intelligent one, we were able to leverage those proven technologies, the ones that we have policies written around, we have procedures in place for, that gave our customers enough security and enough comfort with our layout in our cloud, that because they've been using it that way for years inside of our regular managed environments. So we spent a lot of time focusing on the Nexus 1000V's ability to give us comfort and to give our customers that little safety blanket of, you know what, it's been working for years. We're not doing something new here. We can be comfortable with it and we can accept it moving forward. So we've been able to take some of those features and tie them with a lot of the intelligence and a lot of homework that we put into this cloud from the get-go with our security components to enable things like PCI compliance, mapping back to ISO 27001/2, going through with HIPAA requirements. And a lot of it comes down to just isolation of environments, as well as being able to connect those environments to other pieces of infrastructure inside of our data centers, and to be able to connect those data centers together the way that we have in the past. And it's all basically been because of the VMware, Cisco, and EMC setup that we have running on our cloud today. So as I said, we started that environment back in February of this year. I've gone through a couple iterations, a number of clients on that environment, some in production today, some actually using it to rapidly develop new applications and are looking to roll into production in the very near future. And what we've been able to do for those customers is give them a fast, scalable environment that meets the enterprise security needs that they have, meets the isolation that they have, but actually still being able to give it to them on a multi-tenant environment because of the security underpinnings that have been enabled by our partners all the way through, and that have been then built upon by the engineers at SunGard.
Cool. Thanks, Greg.
No problem.
So we're moving along. Next, a customer of ours that's near and dear to my heart because it's my local hospital. We have Emil from Sutter Health.
Thanks, Omar. Appreciate it. Hi, my name is Emil Versosa. I'm with Sutter Health. Just going to give you a brief overview about our experience with the Nexus 1000V at Sutter Health. Can you hear me? Oh, better?
Yep.
Great. So, just an overview of our data center. Currently, we have a primary data center located in Sacramento, and it houses all our corporate applications and systems that services Sutter Health and our affiliates. In addition, we have a secondary site that services as a disaster recovery site 15 miles away from our data center. Sutter currently has over 2,200 servers in production. In our data center, space and power has been always an issue. We needed a solution that would reduce footprint within our data center. We chose virtualization as that solution that would enable us to free up space, consolidate CPU and memory footprints, and conserve energy usage. So, Sutter's initial target was to virtualize 300 servers. Our first virtualization effort was in our QA environment before moving forward to our production environment. We used the ESX 3.5 and the VM switch in that environment. The challenges that we faced within that environment was that we found that we had our standards and processes for lifecycle, chargeback, and capacity management weren't sufficient for the virtualized and shared environment. In addition, we didn't have support. We ran into support issues with that environment. We didn't have a support model to to support it. Another challenge is coming from the networking side is that network visibility and platform familiarity was a big issue for the network group. It was kind of hard troubleshooting it. All we could troubleshoot is from our upstream switch. We didn't have access to the server realm or the vSwitch. Next slide, Omar.
Sure.
As a result from our efforts with our QA environment, we ended up building a dev environment in order to resolve our issues. Our goal for that environment was to provide non-disruptive management migration practices for the physical to virtual world, and for the network team to have ownership of the network. Through our efforts, we were able to establish and create proper lifecycle and chargeback and capacity management for that environment. In addition, we created a new support team and management tools for that environment. In order to maintain ownership of and a non-disruptive operational model, we chose the Nexus 1000V for our virtual distributed switch. The key benefits that we found from the 1000V was that network operators could provision and operate the VM network the same way that they do with a physical switch. In addition, they could apply the same management and monitoring tools like SNMP, SPAN, and NetFlow to the virtual switch like they would do with a regular switch. The third benefit we found was the flexibility with the port profiles. Not only did it help us have the ability to enforce consistent configuration and policy throughout the server environment, we were able to, it also provides the ability to, if needed, use multi-tiered profiles within our network. So right now, Sutter Health is still in our early stage. Currently, we only have, I believe, 50 physical production servers that are virtualized right now. And in that environment, we're running ESX 4.0, and we made a standard for a standard maximum limit of 25 VMs per physical host. Looking forward, we do have plans to virtualize our whole production network, and alongside with our DMZ. Another thing that we're looking forward to is work mobility for disaster recovery to our DR site, probably looking into like using OTV with the Nexus 7Ks. We don't have them right now, but we're looking into that. Next slide, Omar. So the diagram that you see here, it's just a simple high-level diagram of how we have our Nexus 1000V in place in our production environment. We have a traditional network infrastructure of a core distribution / aggregation and access. For our cores, we use the Catalyst 6509s as our cores, and we also use them for our distribution switches. With our distribution switches, we are running VSS technology to eliminate dependency on spanning tree. For our access layer, we have 4948s that connect to the host. For our host, we use the HP C7000 blade enclosures. And within those enclosures, we have 16 blades. We used a half-height blades, and we have 16 blades per enclosure. And that 16 blades are serviced with a pair of 4948s on top. For each server, we have 6 NICs. 2 NICs are currently used for system VLANs like your vMotion, vKernel, Service Console, and the other 4 NICs are used for VMware data traffic. as you can see there, our uplinks to the 4948s are port channel. We kind of use the channel group auto mode MAC pinning versus subgroup CDP. We ran into issues with that. And as you can see, we use a separate host for our VSM. We have, and they're connected to our distribution layer. We have one host servicing as the primary VSM and a secondary host serving as the secondary VSM for redundancy. And that's basically Sutter's implementation, current implementation of the Nexus 1000.
Cool. Thank you, Emil. Moving on to Algie from Fujitsu.
Yes, howdy, folks. I'm Algie Seat from Fujitsu. And the first slide, I'd like to just point out a couple of things. Down at the bottom there, you see it says external, and then right above that, the 2 points say internal. So Fujitsu America, basically, I take care of internal customers and external customers that we're hosting in our data centers in Dallas and Sunnyvale. And so that's what those references are to. But for the external customers that we host, we have been doing VMware with those customers for almost 5 years now. And but we recently took on a project about a year ago to basically virtualize Fujitsu's internal IT, what actually runs the company's IT. So that's the project that we implemented the NX1000Vs on. And when we started on that project, we came up with a high-level strategy. Basically, we want to virtualize anything that is technically feasible. Everything's not a virtualization candidate, obviously. We had many physical servers that had very low utilization. What we decided on is to standardize on a Fujitsu Primergy server. That's our server line that is in the Wintel space. And these are fairly beefy servers from a memory perspective. They have 144 gig of memory each, so we decided on a 30-to-1 ratio for virtualization. And that's pretty much the way we've implemented. A large percentage have been Windows. There's a few Linux servers that were physical that have been virtualized. The benefits, of course, are many of the same. I don't think I need to go through this. The environmental, floor space, electrical cooling, software licensing, all of those things. Our challenges, and especially internally, were to sell our end users. You know, many of the end users, even though they may have a server that was very lowly utilized, it was their server. It belonged to them, right? And, you know, a sense of ownership. And we had to, you know, work on selling our internal users that virtualization was definitely the way to go. And then we had to translate what we were doing in a physical environment from an operational excellence and best practices. We had to start learning how to translate that into a virtual environment. And we used some of the techniques that we'd use with our external customers because it worked well there, and it also worked well for us internally. And for my initial project internally, this was pretty nice. We have a data center in Dallas. I got to do a greenfield build, essentially. It was a blank space, new network circuits, new servers, new edge switches, new distribution switches, new routers, new core switches, everything was essentially a greenfield build for that environment. So we started off with a couple of clusters, 5 servers, about 125 VMs. As Emil mentioned, he has a DMZ. I think most customers out there, if you look at your business model for internal IT, you probably have an internal behind the firewall environment, and then you have an external web-facing environment. So we're the same. We have that same requirement. So we have physical separation, 2 different data centers, one for internal, one for DMZ. This is essentially for retail point of sale, part of Fujitsu. So that's the environment that we implemented that in for retail point of sale. And future virtualization, what I see down the road is essentially probably 10 to 12 clusters, 400 to 500 VMs. It could be more than that. If we end up converting some of our Spark to Linux, we could virtualize that. That's a challenge, obviously. We're planning a 2 data center model. Essentially, our data centers are in Dallas and Sunnyvale, California. And what we intend to do is basically connect the 2 data centers with the virtual centers in linked mode and implement SRM, Site Recovery Manager, and basically do DR between Dallas and Sunnyvale with replication of mission critical data for applications that are critical to us running our business. So that's kind of the model that we're looking at going forward. Next slide. So during our design phase, when we were designing our environment and deciding exactly how it was going to be architected, one of the things we worked with VMware, and one of the things that VMware suggested to us was to bring in basically Cisco in and take a look at the NX1000Vs. And so what we did with our network team, essentially we brought our network team in to those meetings where we were discussing and coming up with the architecture. And it's at the end of the presentation. I don't want to jump down to it, but and it's available, I'm sure, on the Cisco website. But there is an actual, it's a 3 or 4 page actual point-by-point comparison of the differences in the features of the distributed virtual switch, which are part of VMware, and the NX1000Vs. And if you looked at that comparison, basically our network folks, we went through those items one at a time, and they made a decision. Yeah, this is a got to have, or this would be a nice to have. And at the end of the day, when we got finished with that exercise, basically the decision was made that we required the the things that were in the Nexus 1000V that weren't in the distributed switch. And there were a few in all of these areas. And I'm more from the server side, so the network guys were making pretty much this decision, and we were helping them understand the ESX side of things, the VMware side. But they looked at all the aspects of the NX1000V that are listed there: switching, upstream connectivity, traffic management, security management. And then the other thing that I think Emil also mentioned is our network team is very Cisco-centric, right? They are very used to dealing with physical Cisco switches. They understand physical Cisco switches. They're very comfortable with them. And one of the things that excited the network team is that the NX1000V would externalize that environment where the network team could basically, have a lot more visibility in what was happening with the VMware environment. So that was really important to them and our environment. And what I found from working with those guys, I did the implementation, and then there was part of the network team that worked on me with the implementation, and then we're turning this over as we move along now to our what we call our run team, which handles the day-to-day server activity and operational aspects, and then our network day-to-day run team. So that's what we're getting ready to do. I'm just in the process of doing that now. We've been running this in production for about 7 months now. And I would say that talking to the network guys now, they would say that from day one, when they looked at the NX1000 virtual supervisor module, they said that from their experience, about 80% of the command line stuff that they had to do was very familiar to them. It was very easy for them to understand. There's a few, I would say 20% of commands that they had to pick up, basically of how the VSM interfaces with the virtual Ethernet module that runs on the ESX host. So that wasn't a huge learning curve for those guys at all. They were very comfortable with that. So that's basically how we've implemented this. And again, down at the bottom, it was implemented by the server team and with some network folks, and now it's being transitioned to the network team. And at this point, they'll be handling code updates, port profile creation, modification, synchronization with the upstream switches, all of the things that the network guys do. And monitoring also is important to us. We wanted a robust SNMP environment. That's pretty much a standard that we use to try to do all of our monitoring. We like something a little more advanced in monitoring it versus just ping, whether it's up or down or not. So there's a rich set of MIBs for the NX1000V, which is great. So you can look at a lot of different aspects of the NX1000V. And the last thing is I'd like to just give you a high-level drawing here of, this is an example of one of our environments. It's kind of there's a lot on this slide, but you can see that our standard on our server configuration is 10 NICs, essentially, on each server. There's a couple of onboard NICs. We have a quad 1 gig NIC card on each server, and we have two 10 gig dual ported cards also for a total of 4 10 gig NICs per server. And at the top of the drawing, you can see at the top of the drawing outside of the NX1000V, what you see there is vMotion. We made a kind of a strategic decision for taking vMotion outside the management of the NX1000Vs. And if you look at the bottom, outside the box is our service console for our ESX host. We also have them on a management land outside of the NX1000V. And then basically what we run through the NX1000V then is all of the user access for all of our users, right? Which is what you see in the middle there. That's connected to the uplink profiles in the middle there. And just a couple of things I want to point out on the right-hand side. There's different ways of doing this implementation, as mentioned. Of course, I'm with Fujitsu, so we use Fujitsu servers for our environment for edge and distribution. Those are the switches you see on the right-hand side there. They're Fujitsu 10 gig or 1 gig switches with 10 gig uplinks. So, works fine. Some people have told me that, this won't work unless you have an upstream Cisco switch. That is not true. It works fine because we've implemented it. It's perfectly great. Works really well for us in our environment. So that's not an issue. And, this is a mixed environment, so we do have Cisco 7000 core switches, and we have Cisco routers. So there's no problem that we've had uplinking our distribution switches to the core or to the router for our DMZ. Works great. That fourth bullet, I mentioned it already, vMotion and ESX. Service console is not managed by the NX1000V. And then the last thing I wanted to mention is since we have been on the NX1000V for 7 months now, we have had a couple of problems. We worked through them, very well with Cisco NX1000V TAC, and we've migrated from release 1.2 that we started with to 1.3, and then a few weeks ago we migrated to the current NX1000V release, which was 1.3a. So that's where we are right now, and I think the Nexus 1000V has worked very well for us. Our network team has bought into it, obviously, for the reason that they have more visibility and feel as they're part of the team that's managing the virtualized environment from a network perspective. And so that's the implementation that I worked on at Fujitsu internal for the last year.
Cool, thanks, LG. And Ken, you can bring us home.
Hi, I'm Ken Schroeder from Cisco IT. I've been working on our data center virtualization strategy since 2005, I guess. If we look at Cisco's global data center footprint today, we have over 50 data center facilities with about 12,000 production servers in those facilities that are customer facing. So far, we've got about 50% of those 12,000 servers virtualized. And if we look, we're trying to move, obviously, from our non-UCS platforms to the UCS platforms. Prior to putting UCS in our environments in N1K, we had about 4,000 virtual servers. 2,000 of them have already been migrated to the UCS platform, and we've added 2,000 more over the last year since we started our migration strategy. So we're looking at being 100% migrated to UCS and N1K by the end of our financial Q2 in FY11. And we've been pushing a virtualization first strategy for a long time. So our targets have been 80%, since probably day one. It's been a very slow, move that way, but we are building, massive, build up to, customer adoption and stuff to be able to make that happen. We started out with, when we were on our non-UCS platform and ESX 3.5, we started out with some target ratios of a 4 vCPU to PCP core ratio for our target over subscription rates, and 1.5 gig of memory to 1 gig of physical memory for how we were trying to position our growth. What we've seen, we migrated, as we started to introduce UCS, we introduced vSphere, with a lot of the optimizations that came along with that over our old hardware platform. And what we see is we're very underutilized. So we're really aggressively trying to manage our oversubscription and underutilized virtual machines. There's a fairly large staff of Cisco employees in IT that are trying to establish new policies and get customers to, or our clients to right-size their virtual machines and be more effective in our utilization. We look at our management model. Before we were at UCS and N1K, we didn't really, a network team didn't have any visibility into the network. We had 4,000 virtual machines out there that basically they could only be seen on the gateway via MAC address. So any troubleshooting and those sorts of things, very difficult to isolate, very difficult to really get any good data on. Our hardware platforms at that time were kind of spread out. The VMware team themselves managed the VMware and the servers that they were using. And the other teams that were deploying bare metal and so on, they managed their own hardware separately, hardware replacements, setup, implementations, et cetera. What we see today, we go to UCS and N1K, I look at the UCS platform itself. It's kind of a layer 2 extension. It's really a layer 2 device. We run it in end host mode, so it's not really entirely layer 2. It doesn't run spanning tree or anything. But what we see is how we managed our VMware environment, where that team managed the port groups, the L2 kind of VLAN IDs and those sorts of things. They naturally led to taking our UCS platform as a layer 2 extension and allowing our VMware team to take over the UCS platform as a management entity. So now not only does our VMware team manage our 600 plus virtual machine or ESX servers in the data center, they're also managing our UCS rollouts, managing VLAN updates on our UCS switches, vSAN updates. We have a lot of that automated as far as initial setup, so we're pushing out some standard policies and profiles to the UCS, and as well as service profiles, et cetera, that make it very easy for it to be managed. But as far as day-to-day managing that, and the network team doesn't manage our UCS devices internally today. But what we are, we introduced N1K, and now the network team has visibility into 6,000 servers that they've lost visibility to inside our data center. So it's a huge net gain. Obviously, it's a lot more for the network team to be able to analyze and look at. But it also gives us a lot of advanced capabilities if we want to do QoS, ACL, type things, and along with the centralized management of the VSM, being able to control up to 64 ESX servers today, that portion of it alone has a huge benefit for us from a VMware operations standpoint. Because when we look at, a client comes up, we have some special security demands where we need a new network, we need some new VLANs, all that becomes a multi-point handoff process where prior to, networking had to go out and create, the network, and they had to let the VMware team know to update and create the port profiles on the UCS or the port groups on a standard vSwitch. And now networking can go out, they can create the subnet, they can push the port profile out, and it's automatically there and ready for client utilization. Another thing that what we've done, since we've gone to UCS and N1K, we've introduced what we call CITIS, Cisco IT Elastic Infrastructure Services. It's basically our internal cloud platform, and so that manages all of our VM deployments. We have offloaded some of that that was traditionally managed out of our VMware infrastructure team, as far as provisioning of VMs, has gone to an automated system. So the last slide here is basically what the Cisco IT reference architecture looks like. We're running UCS 6120s. We have B200 M1s and M2s that are in our environment, and we're also running the QLogic Menlo and now the Palo adapters on our server platform. So we have an N7K distribution layer. We're still running our Cat6K service layer to run our ACE modules, NAM services, virtual firewall services as we need them. And then, of course, we use our 6120s to terminate them 10 gig directly up to the N7Ks. Down at the bottom where we're running our VSMs today, I have the N1010 in there. This is more of a future-looking slide for us because we haven't gotten the N1010 in production yet. We have it in our pilot environment. We've been running it for 6 months or so. And I don't know if everyone knows about the N1010 or not, but the N1010 basically is it's a C200 rack mount server. It runs NXOS code, and it allows you to run up to 4 virtual supervisor modules on the N1010 itself. So you can scale that out as a single management entity, and it also returns the control for network over to a hardware platform for the network team. It's one of the things that we struggle with as we look at implementing VSM. Is the network team's like, well, how do I get access to my console? Like, well, you got to log into Virtual Center and get on your, the Virtual Center client to get your console access. And of course, that's not ideal to a team that's never used, our virtual infrastructure client, Virtual Center servers. So with N1010, it allows that full control back over to their, standard console access sort of thing. So we are looking at implementing that. But today, what we see is on our 6120 clusters. Primarily, operations is deploying like 20 node ESX clusters. We have about 30 terabytes of EMC attached to each 20 nodes. And then we'll have N1K on there with several port groups. We're looking at port profiles, and we're looking at going up to about 145 different VLANs per ESX cluster under an N7K environment. And if we look at a traditional Cat6K distribution layer, we've limited it to about, I think, 32 because of spanning tree and logical port calculations. So, what does this really all mean? I mean, what we have is highly converged, design, some very simplified management points that help, get us operational quickly, allows us to make changes quickly. UCS has been a big benefit for us. We've been using VNIC templates for doing, VLAN additions to the servers and, kind of a 1 or 2 touch operation, and then, the network team being able to manipulate the port profiles very easily and rapidly from a central location.
Cool. Thanks, Ken. So I'm actually going to open up for questions a little earlier. So if you have questions, if you can line up by the mic. Or if you have a question right here, we can grab it right now.
You guys
yes.
This is the Cisco. It sounds like you've got the Nexus 1000B being managed by the network team, but you've got the UCS and then host node being managed by the server or VMware team. Does that cause you challenges in an operational team? Because it seems like one network component is being managed by the networking team, one's being managed by the VMware team.
Did everyone hear the question? So the question is if there's a split between management of the 1000V versus the UCS, and if that creates any issues or challenges.
So I think that's yet to be seen, but I mean, we have a very tightly run organization as far as our network and the virtualization services teams. We have very good partnerships. I think that really helps. So for us, it's really not been a big of a challenge. It's more of a coordination and stuff, which we've already kind of worked out a lot of the handoff points and things, from our traditional model. So this is just an evolution of that. From the UCS perspective, we've been doing that for quite some time, and that really hasn't been that much of a challenge that I'm aware of.
Question over there?
Yeah, so I noticed a couple of interesting breaks from architecture that I'd like to ask about. With Sutter Health, you mentioned that you separated your VSMs and put them on dedicated hosts. And then with Fujitsu, you guys talked about your service console and your VM kernel not being switched by the N1K. And then I was wondering, the rationale for those two, and then if those architecture decisions are also what Cisco IT chose to do, or is the direction with the 1010 to separate off some of the VSM traffic, or separate some of the service console or vkernel traffic.
We can just work our way down the line.
Okay. Yeah, we chose using separate hosts because we wanted the rationale behind that. We wanted to make it look like kind of like the what do you call it, the 1010.
The N1010.
The 1010 VSM. Network wanted control over that host where we can vSphere into it, go into console easy, and just basically manage that box. So that's our rationale behind that.
Cool. LG, how about from your perspective?
Yeah, as far as our perspective, it was the ESX service console. We just considered that to be a management type function, and it was critical for our server team to be able to get to that, and that's kind of a standard thing that we do. We like to keep our management traffic separate, and so we considered the ESX service console to be management type traffic. So that was why we put that on a VLAN that was outside of the NX1000V. And then as far as the vMotion, our environment is 2 VMs that are in HA mode pair, obviously. We set a DRS rule that says run the active one on one host and run the standby on another host. And we did test for a while with the 210 gig network interfaces being managed by the NX1000V. We did a lot of testing with failover and actually destructive failover. Walking up to a machine that was running the primary active VSM and just pulling the power cord, that kind of testing to see if it would fail over. We did have a problem, I believe, on 1.2 where the VM got misprogrammed, and when we updated to 1.3, that problem no longer existed. So that was something that was taken care of with the code update. And then from just looking architecturally and looking at letting the network adapters that are actually being used for vMotion, if you think about that a little bit, it's kind of an interesting thing because the network adapters that are doing vMotion are being managed by the VSM and the VIMs that are running on the ESX host, but if a host goes into maintenance mode, or a host goes, or you have to do software maintenance, whatever, and you've got to migrate all the VMs off of a host, the VSM, the active VSM that's actually, managing the network adapters being used for vMotion is actually being vMotioned. So we just decided to make a decision to, take that outside of the NX1000V. We just, we've got a 30-to-1 ratio. If we have, if we have to vMotion 30 VMs, we don't want the VSM vMotion to be involved with vMotioning the VSMs. but vMotion does work fine with the VSMs. We've done a lot of maintenance, a lot of testing, and they do vMotion just fine. And they can both run on the same physical host. But the DR rules will kick in if the other host comes out of maintenance mode, and it'll get vMotion back to apply the DR rules. So,
thank you. Ken?
From a Cisco IT perspective, today we run our VSMs on it's one of our general population clusters that's not running. It's not been migrated to N1K yet. Obviously, we have a large population of VMware infrastructure. With the idea being we're going to move that, offload it from our VMware clusters to the N1010. We run our vSwifts and we run our VM kernels all go through the N1010 today. vMotion, like similar to what Algie said, we use DRS today where our VSMs are running to use an anti-affinity rule between the active N1K instance and the standby N1K instance. I think that addresses your question.
Cool. Question in the back. While she's coming up, I'm the marketing guy, so I have to make a pitch for some of the flexibility of the platform, which we're very proud of. I mean, across this panel, you've heard a number of different deployment options, and across a multitude of different vendors. And I think that's one of the things we've seen such strong customer uptake, because it very folds in very easily to what you're probably running in your data center right now without a whole lot of churn. Question?
So this morning I attended a session which talked about, from Cisco, which talked about hypervisor bypass technologies and talks about bypassing the virtual switch. Mm-hmm. So just a question to the panelists is there anything specific in your environment where you require a vSwitch? So tomorrow if Cisco offers you the hypervisor bypass technology with bypassing the virtual switch, is there something that will prevent you from moving to that technology?
So the question is, would you take advantage of hypervisor bypass? I mean, you can if you run UCS right now.
Yeah, so I can speak to this. We've internally for Cisco IT, we've done an analysis of Palo PTS, which is part of the, I guess somewhat integrated with the hypervisor bypass and standalone. What we've chosen for us is we want to go with N1K, which I guess you really can't use N1K and hypervisor bypass. I don't think they're kind of mutually exclusive. For us, it's more of the ability to get features rapidly into our environment. We feel with the N1K software stack that they can be very agile in delivering new features. As far as UCS integration and those sorts of things, if going down that path, certainly we've looked at it, we've tested it, it functions very well. But the ability, some of the features are limited as opposed to what you can get on the N1KV, and more about the speed of delivery and getting new things into our environment. And also, it presents some limited vMotion domain challenges that we wanted to try and stay away from.
Yeah. I mean, for most of our customers, we have hypervisor bypass available, say, on the UCS. So again, it becomes a deployment option from your perspective, right? You can have the flexibility and agility of the software switch, or you can use the hardware features if you're looking for performance, those kinds of things. I had one more question there first, and I'll come back to you.
So as the technology, the Nexus 1000 technology gets more widely deployed, do you see a change in the reporting structure? And this is maybe specifically a question for the Cisco person. Do you see a change in the reporting structure where with the coexistence of UCS and Nexus 1000, there is the server team and the networking team are reporting to the server team, or vice versa?
Probably not at Cisco.
At SunGard, we actually ended up shifting to an ITIL structure for support and maintenance, and with that, we ended up shifting to less being focused specifically on network, less being focused specifically on server, but more about incident level and response level. And from that standpoint, when we take a look at the environment itself, the environment is being managed less from I'm a storage person, I'm going to handle the vertical stack of storage, and more on integration across the board. And so what we've actually seen, and what we're seeing a lot more now that we're starting to move this VBlock model into our ITIL support structure, that in order to actually sufficiently support the environment, you can't just stay focused on one piece. You can't just have a networking guy, you can't just have a storage guy. what we've ended up doing with the converged networking, with 10 gig Ethernet all the way through, and then breaking out higher up for storage versus for server, and for for the server traffic over like the traditional network. You don't have the ability to sit there and have those groups be separate. And from a planning perspective, from a recovery perspective, from all of those different areas, the only way that you're actually able to take advantage of new technology is to not silo your environments. So I see a lot more of it moving towards like the ITIL structure, where it's around what's the function they're performing, not necessarily what technology they're acting on. And I think with that, you'll see the Nexus 1KV acceptance and the ability to incorporate a lot of its technologies that come with it into an architecture will get increased, and it'll be much easier to take advantage of as soon as you start shifting to what is the team's primary focus in terms of what are they trying to accomplish versus what technologies are they skilled on.
That's actually a great question, right? Across our customers in general, we find virtualization, some of these transitions really causing customers to re-examine their org structure and how they manage things by function versus necessarily by technology. Question?
So to go back to Ken's question real quick, there's a lot of confusion out there about and I'm glad you brought this up, can BBS and Nexus 1K and vSwitch all work together? And a lot of people in the market don't realize I can do all those things at the same time. The other thing with the Palo, my question is, since you're a PM on the Nexus 1000B, are you seeing?
I'm just a marketing geek. There are actual PMs in the audience who would beat me up if I took that. But
I would assume there's going to be a lot of discussions in the next year about Nexus 1000B with Palo.
That's actually a great. That's a great lead-in. Oh, sorry. The question. I'm going to paraphrase the question about what we're going to be doing in the coming year around Palo and the 1000V, and we're really going with our virtual aware networking. So it's a great lead-in. We actually are Ed Bugnon, who is the CTO of the business unit that's responsible for this technology, has a keynote at 11 tomorrow. Has been digging a lot into kind of what we see in the near-term future, some new features, and a couple of product announcements, and then kind of long-term plans around networking and I/O for VMs.
So we do use Palo and N1K together, but we don't use the PCI pass-through and the Palo PTS function. So they are compatible, right? But you can't use the PCI pass-through and the Palo PTS in conjunction.
Is that because of limitations right now on that?
Well, I mean, what Palo PTS is a DVS is itself, right? So you can't be. I mean, you just can't do it. But as far as from the Palo perspective, right, we can do multiple uplinks taking advantage of the Palo adapter itself. Since you can have 4 uplinks, you can create them to 2 different system uplink profiles in the N1K if you need things for segregation or security purposes. That does allow you a lot of flexibility from that perspective.
Question? That's a great question. I believe they'll be posted somewhere. I can get back to you and find out. They usually are. So the question was if the slides can be posted online. Sorry. Question back here?
Yeah, I'd love to use NetFlow and span, but my server guys would freak out about the host utilization. Has anybody put it through its paces using NetFlow and span, live in your production or your internal network?
We have, although I don't have the information handy. But we have found utilization being not comparable to what they get on a normal DVS.
Network operation guys usually did that. We didn't see any issues with it.
Yeah, similar. I mean, we have tested span and we've used it. It's not widely deployed into our M1K as a production standard right now, so I can't speak to it from that perspective.
There was another question over here somewhere. Yes.
So we're looking at the design there for the next 1000B, the physical servers that all virtualization design. I see some are plugged into the access layer and some are plugged into the distribution layer. Is there a preference? Because the way I see it is the next 1000B is an access switch, and I don't know where first they'll have to go into an access switch and go right to a distribution switch.
So the question is whether the thinking between deploying 1000V as an access layer or an AG layer technology. So
basically port aggregation. If we put it towards our distribution switch, we run out of port capacity on it.
Yeah, I mean, when we designed this,
we're running 1 gig,
okay.
1 gig, so it just made sense we could get access.
Yeah, I mean, we designed the switch as an access layer technology, right? But folks, adapt it to whatever their particular needs are. Question back there?
Is there any particular considerations to use actually virtual VSM versus like physical VSM? I got a sense like seem to be able to using physical VSM to control their network. So am I wrong or?
Actually, from our perspective, we're leveraging the virtual VSMs and running them in a completely separate virtual environment to manage our actual production environment. So we are leveraging the virtual ones to both assist in capabilities for backup, restore, as well as recovery.
How about other actually?
Can you repeat the question?
How about other folks?
So virtual VSM, physical VSM, any design preferences, or what drove your decisions?
I mean, we're using the virtual supervisor module. I don't really know there's a physical offering.
You mean the 1010?
So the 1010 virtualized is a physical offering for housing multiple virtual supervisor modules. So the N1010 itself does not serve as a VSM. It serves as a host of many VSMs and other virtual service blades. So that product itself will host the N1K VSMs up to 4, I think, today. And then there's also a whole another offering of virtual service blades that will begin to show up that will go and run on that hardware platform itself. But right now we run on a VMware. It's on VM. Our VSMs run on top of VMware. We want to move to the N1010 for the centralized management and ownership for the network team, but the VSMs themselves are still virtualized.
Time for one last question. Going. Way in the back.
Have any of y'all seen any measurable performance differences with the 1000 over native VM networking?
The question is, have you seen performance differences between the 1000 VM and a DVS environment, or? Okay. Did any of you do any?
All the testing that we've done has been there's no difference.
Cool. Thank you for joining us today. Hope the session was useful. Thank you.